Aspects of a quadratic graph. Vertex form, which we've seen a lot, is the form ax minus h squared plus k, where h comma k is our vertex. So a little bit further about our vertex this time. It's going to be your highest, your maximum, or your lowest, a minimum, point of the parabola. We also have something called an axis of symmetry. This is a line that divides a parabola into mirror image. It's a vertical line. In standard equation form, the formula to find the axis of symmetry is just x equals whatever your h value is. Anytime you're asked for the axis of symmetry, make sure you answer it as an equation. X equals a number. Minimum or maximum, a description of the vertex of a parabola. The y-coordinate of the vertex point is named as the maximum or minimum. Our domain is the set of x values for a quadratic that give real number outputs. For a quadratic equation, the domain is always all real numbers. You can write that out, or you can make this little double bar r. Your range is the set of all possible outputs. In vertex equation form, the range is either going to be y is greater than or equal to your k value, or y is less than or equal to your k value, depending on if the graph opens up or down. Okay, here's the steps we're going to follow to graph our quadratic. First of all, we're going to find our vertex using hk. Then we're going to find the axis of symmetry, which is always the line x equals h. Then we're going to make our t-chart and plug the vertex in, put in some points above and some points below, just like in our last concept. All right, we're going to graph f of x. We need to label the vertex and the axis of symmetry, as well as give the domain and the range. So first of all, let's start filling out this right side. We need to figure out what our h and our k values are. If we look at our equation, our h and k are -3 and +4. So our vertex is the point -3, 4. Remember, we always change the sign of h whenever we pull it out of an equation. Next, our axis of symmetry we know is the equation x equals h. So it's just going to be x equals -3. I'll show you what that looks like graphically here once we get to the graph. Our domain is pretty simple. It is always going to be all real numbers anytime we're dealing with quadratics. Our range is pretty easy to find whenever you're looking at the graph, but there may be times that you're asked to find the range without a graph. So we're going to find it without a graph, and then we'll see in a minute how it makes sense. So anytime our graph is opening up, our range will be y is greater than or equal to our k value, because our graph is going up, greater than or equal to. Anytime the graph is opening down, we'll have y is less than or equal to our k value. So looking up at our equation, we're just looking to see if it's been reflected or not. So since we've got a negative out in front of this 2, then I know our graph has been reflected and is therefore facing down. So our range is going to be y is less than or equal to 4. Again, less than or equal to because our graph is facing down, and 4 is my k value. All right, let's fill out our table starting with our vertex in the middle. Now we're going to plug each of these x values into our equation to see what the y coordinates of each point are. If we plug -6 into the equation, we're going to get out -14. If we plug -5 into the equation, we will get out -4. And if we plug -4 into the equation, we get out 2. Since we set up our table with our vertex in the middle, we know that the other y values here are just going to be 2, -4, and -14. Okay, let's graph. We do have a 14 going on, so we're going to need to move our x-axis up so that we can fit a -14 on our y-axis. Now we'll be able to fit all of our points on our graph. Okay, go ahead and start by graphing your vertex and then the other points around it. Great, now let's go back and talk about the range here. So our range we said is y is less than or equal to 4. Let's look at why that makes sense. My graph, if I kind of look over, is going to cover the y-axis from 4 and down. So my graph doesn't have anything to do with when y is, say, 100, because my graph is facing down. So that's why it's less than or equal to 4. If it had been flipped up, then it would have been greater than or equal to 4. For our next problem, we're going to do the same thing. We're going to graph the function, label the vertex and the axis of symmetry, and give the domain and range. So let's start off by finding our h and our k value, our vertex, and our axis of symmetry. H and k are going to be 3 and 7. Remember, we always change the sign of h. So our vertex is 3, 7. Axis of symmetry is x equals 3. Domain is always all real numbers. And our range this time is going to be y is greater than or equal to 7. The reason why is because I do not have a reflection. There's not a negative out in front of my equation. So I know that my graph is opening up. All right, now to fill out my table, we're going to start with the vertex in the middle. Go up by 1s on the x, and then plug each of those x values into the equation to get our y values out. Now I notice here that we do have some not so great decimals, not just a clean cut 0.5. So I am only going to graph these points that have whole numbers. I'm going to move my x-axis down so that I can fit 13 on here. And I've got my graph. So let's look at our range really quick. We had y is greater than or equal to 7, which makes sense because my graph hits my y-axis at 7 and then goes up. Independent practice. I want you to pause your video and complete the problems and then restart to see my answers. I'm now remembering that in every example I forgot to show you the axis of symmetry on the graph. So make sure you go back to your examples in your notes and draw the axis of symmetry in. For this problem, it's this dashed line right here.
All right, and finally, you can check your number 2. So g of x equals 2 times x minus 2 squared plus 5. So our h and k values are at 2, 5, and that's our vertex. Axis of symmetry is at x equals 2. Our domain will be all real numbers, and then our range will be the y's that are greater than or equal to that k value, the y value of the vertex, 5. And then if you check your table of values, I've got one correction to make here, and so we'll have our vertex at 2, 5, and then numbers around it will be these values, and then your parabola should look like the one that I have graphed on the left.